Right, so in this podcast, we're going to talk about calculating voltage. All right, so battery manufacturers obviously have to make batteries. They want to use things that give a specific voltage and last a specific length of time. So our equation for calculating E, all right, it's just called E, is, all right, so it's simply the E of reduction minus the E of oxidation. And this table is just a list of E values, all right? They're called electric potentials, all right? So that's what E stands for, electric potentials, and they're measured in volts. So this is 1.5 volts, and so on, volts all the way down. So what we have some equations here, and simply we have to identify what is the reduction equation and what's the oxidation equation, or take reduction minus oxidation. So if we look at Fe, it's a plus 3, it goes to a plus 2. Oh, look at that. Fe is being reduced. So I'm going to come over here and look for Fe, and it is right here. So its potential is 0.77 volts. And I'm going to subtract the oxidation. Well, because we've already identified iron as reduction, magnesium better be being oxidized. So it's going from a 0 to a plus 2. Alright, so yes. So we just need to find magnesium. Start at the bottom. So its value is negative 2.37. So we're going to subtract negative 2.37. So really we're going to end up adding that, because if we subtract a negative, we add, and we get a value of 3.14 volts. Alright, and that's all this is. So as we go to our next one, bromine is a 0 because it's an element by itself. Over here it's a minus 1. Oh, that's being reduced. So I'm going to come over here. Here's bromine, 1.07 volts. And if it is being reduced, nickel better be being oxidized. So I'm going to simply do 1.07 volts minus nickel, which is right here, which is negative 0.25 volts. And we get something that's 1.32 volts. Alright, easy peasy. Next one, we have lead, which is a 0, going to a plus 2. Oh, that is not getting smaller. So let's look at copper. It's plus 2 to 0. So really my copper is my one being reduced. So I'm going to find it. It's right here. 0.34 volts minus my lead, which is right here. Negative 0.13 volts. So we get something that's 0.47 volts. Alright? Our last example is important, so hopefully you're still with me. Let's see. Aluminum starts at plus 3 because it's an ion, goes to an element, so that is being reduced. So right here we have negative 1.66 volts minus zinc, which must be being oxidized. So minus negative 0.76. And notice here we get a value that's negative 0.90 volts. Okay? And what I want to draw attention to is the negative in front of it. That negative, alright? And that is something that's bad. So if you saw, or in class, are predicting whether something happens. Let's look at this. So we have aluminum right here, and we have zinc right here. Alright? So notice that is not our northeast, northwest, southeast rule. It is our northeast, southwest rule, which means this does not happen. So what I want you to notice is all of these were positive, okay? And all these are going to fit our northwest to southeast rule. So positive voltages occur naturally. They happen. Negative voltages do not occur. Okay? So I can give you a negative voltage, but if I were to ask you a follow-up question, does this occur spontaneously? Does this happen naturally? The answer would be no. Alright? So negative E values we're going to say do not occur, or let's just say they are not spontaneous. And spontaneous basically just means do they happen naturally? Spontaneous. Whereas positive E values are known as spontaneous, or they react. Okay? So positive E's occur naturally. or they are spontaneous. And batteries better be made out of things that make positive E's. Okay? That is it.